Hello there guys, and welcome back to another epic and extra maths video. In this video we're taking a look at how we might differentiate a to the power of x, where a is a constant and it's being raised to the power of x. So it's kind of like e to the x, you know, differentiating e to the x, but not necessarily e. Actually a could be any number here, any positive number. We've got to have positive numbers for this one. You'll see why in a second. So let's have a look. How do we differentiate this thing? First steps first, we just need to remember the note, which is that the derivative of the natural log of x is 1 over x. This is a really important result. It just happens in loads of derivatives that we need to do using implicit differentiation. And that's what we're going to do today. We're going to implicitly differentiate this. So we're going to say that y is equal to a to the power of x, okay? Then we're going to take natural logs of both sides. We're going to get the natural log of y is equal to the natural log of a to the power of x. We're then going to use the power rule for logarithms to bring the x down times by the natural log of a, just like this. So the x just comes down like this, and we are here. And then at this point, we want to differentiate both sides implicitly. So the derivative of the natural log of y with respect to x is 1 over y. And because it's a y and not an x, we times by dy dx, as always, with implicit differentiation, okay? So on the right hand side, what we have is the derivative with respect to x of x times the natural log of a. Now it's worth mentioning that a, again, is a constant, which means the natural log of a is also a constant, which means that we don't need to do any product rule or anything like that. We simply differentiate with respect to x and allow the natural log of a to be a constant, which means that it's a constant times x. When you differentiate that, you just get left with the constant. So the x disappears and you just get the natural log of a like so. Finally, we can multiply both sides by y, and we get dy dx on its own is equal to y times the natural log of a. Okay, so technically, you know, as always, we're kind of done, but we're not exactly done, because there's another thing here. We don't want our derivative to be in terms of y, because it's not very nice. What we can do is give it in terms of x. And we know what y is in terms of x. y is a to the power of x. They are the same thing. Y is a to the x, which means that we can replace y down here with just that. We can say that dy dx is equal to a to the power of x times the natural log of a. And this is the final result. This is the answer. The derivative of a to the x is simply a to the x times the natural log of a. So, for example, if we wanted to differentiate, let's say, 2 to the x, this would be 2 to the x times the natural log of 2. That would be the derivative, just like that. Now, if we wanted to let a equal e, the number e, 2.7 and so on, this would be e to the x. And what should this be? Well, the derivative of e to the x should be e to the x. It should be. So let's try that. Well, okay, so whatever the base is, that just stays there, and we times by the natural log of that base. So the natural log of a, that's the natural log of e, like that. But what is the natural log of e? The natural log of e is just the number 1. Because the natural log of e is the logarithm base e of e. What number do you need to raise e to the power of to get e? Well, just the number 1. So it's the number 1, which means that the derivative of e to the x is e to the x. There you go. So that's quite nice. That's quite a good sort of thing that we've got right there. So if you guys enjoyed this video, let me know. Tell me in the comments below if there's anything that you would like to see, and I'll see you guys in the next video. Cheers.